I'm Emily Hummel.
And I'm Lucy Mervar, and today we'll be demonstrating the experiment, the disappearing blue.
Today for the experiment we're going to be using a 500 milliliter Florence flask, and it has a stopper to fit, a 300 milliliters of water, 8 grams of potassium hydroxide, and 10 grams of dextrose, and 6 to 8 drops of methylene blue.
Since the experiment suggested that we use 6 to 8 drops of methylene blue, we decided to go right in the middle and use 7 drops.
First, we're going to dissolve the potassium hydroxide in 300 milliliters of water.
We will pour the potassium hydroxide in first, and then we're going to add the water afterwards. And since we're dealing with potassium hydroxide and it has a very strong base, we decided to wear safety gloves and goggles. Once this completely dissolves, then we're going to continue to add the 10 grams of dextrose.
And then, as she's adding that, afterwards we're going to add the methylene blue once it's completely dissolved. And the methylene blue is an indicator, and then once you shake it up, we'll have to let the solution sit for a minute so you can see part of the reaction.
We're going to dissolve this, and we want to make sure that it's completely dissolved to make sure the experiment works effectively.
And again, we're adding 7 drops of methylene blue. They said that 6 to 8 would work.
Put the stopper back on and shake this up.
And then you're going to have to let it sit for a minute, and it's going to turn colorless.
For time's sake, we have a pre-made solution already here to show you guys how it works.
And as you can see, the colors disappeared, or has it.
Once you shake the flask, the blue will reappear and it will become oxidized. Once you stop shaking it, you'll see that the blue will begin to go away, and this will happen until all the oxygen in the flask is gone. This happens due to the oxidation. It turns blue due to the oxidation, because once oxygen is added, it makes the methylene indicator turn blue, and then once it sits for a minute, it goes back to a colorless form because it's being reduced by the dextrose.
Shaking the solution raises the concentration of oxygen in the mixture, and as it oxidizes the methylene blue back to its blue form. The dextrose acts as a reducing agent and reduces added methylene blue to a colorless form. A reduction is when oxygen is removed from the substance.
So in this first equation, it represents the solution when it begins at its blue state, containing the methylene blue, which this is it when it's blue and oxidized, and then this is the dextrose that we added, and this is the potassium hydroxide. And when you put that together and let it sit for over a minute, it'll turn to that clear solution, which is this right here.
It should turn clear soon.
You have to let it sit for a minute and then it'll turn.
And in the second equation, it represents the methylene blue when it began at its colorless state. And once we began to shake the flask, we added oxygen, causing the solution to oxidize and return to its original blue state. And again, it will continue to keep going back to blue until all the oxygen in the bottle is blue. And as you can see, it's turning clear.
There are many real-life applications that have to do with methylene blue, and according to the Mayo Clinic and Flynn Science Incorporation, methylene blue is often used in surgeries to dye parts of the bodies. A lot of the time it's used in coronary artery bypass to dye blood vessels for surgery, and it's also used in other vascular procedures.
Another application according to the Mayo Clinic is it's used to treat a condition called methemoglobinemia, and this is when the body cannot deliver oxygen through the blood and to certain body parts. Methylene blue is used as a therapy for drug-induced disease by administering it intravenously. And then,
These are our references.